Hey guys, so welcome to the part 2 of the topic 8 spectroscopy video. So here I have a list of the 3 basic formulas that's going to show up a lot in topic 8. E stands for energy, energy per photon actually. H is Planck's constant, which is 6.626 times 10 to the negative 34 meters squared kilograms per second, or also joules per second. V stands for frequency. C is approximately 3 times 10 to the 8 meters per second, which is the speed of light. And lambda is wavelength. So you're probably asking, oh, what's the importance of this? Well, there's a lot of math calculations. That's why we went through what we did what we went through in the first video in order to prepare you for this. So let's see. We're given 727.5 nanometers as a wavelength. Let's see, we could use this formula to find out what the frequency is. Because we have speed of light equals wavelength times frequency. But we're given wavelength, and we know speed of light's a constant. So we could solve for V. So V is going to equal speed of light over wavelength. But remember, wavelength is always in meters. So we got to convert this into regular meters. And nanometers actually times 10 to the negative 9. So we could just turn that into 10 to the negative 9 meters. Now let's just plug that all in. 3.008 per second over 10. Alright, cool. So let's do what we did in the last video. Let's worry about this first. So when you divide 3 by 727.5, you get 0.004123. Now let's look at the exponents. Since you're dividing by a negative exponent, you're going to end up adding. So it's going to be 9 plus 8. So you're going to have 10 to the 17. Then the meters cancel out. It's negative 1. But you're not done yet. It's not the proper way to write the number. You have to move it 1, 2, 3 times. And then remember, when we're moving it to the right, we always subtract. So we're going to subtract 3 from 17. You're going to have 14. So it's going to be 4.123. It's 10 to the 14 s minus 1. And that is our frequency. Now that we have frequency, let's use a harder formula, which would be this one. We need to calculate energy, because we have H, that's Planck's constant, C, that's another constant, and then we have lambda. Now, let's find the energy. E equals hc over lambda. Is that equal to H, Planck's constant, 6.626 times 10 negative 30 m2 kg. Don't let the units frighten you, because we all know energy. Well, you guys don't know that, but energy is always going to be joules. That's one thing you learn, joules. Remember that. So energy is always in joules in chemistry, well, for the most part. And then speed of light is 3.00 times 8 meters per second. Sorry, it's kind of clashing. I apologize for that. You divide that whole thing by the wavelength, which we have as 727.5 to the negative 9 meters. Alright, so let's multiply 6.26 times 3, then divide what you get by this number. By doing that, you get 0.0273. Now let's take a look at the exponents. Negative 34 plus 8, and then you get, let's see here, 34 plus 8, you get 26. And then from there, you're going to end up adding a 9. So negative 26 plus 9, and you're going to end up with negative 17. And all these units cancel out. And ultimately you're going to end up with joules. But we're not done yet. You have to move it twice. And since we're moving right again, subtract it by 2. So ultimately you'll get 2.73 times 10 to the negative 19 joules. There you have it. Way easier method, just in case numbers or units confuse you. Just worry about the whole number first, and then worry about the decimals. I know this video wasn't really about spectroscopy, and you should learn that on your own. This isn't really that great of an example, but I'm just here to show you the math and the concept I use to make it way easier for me. Thanks for your time.